This is Algebra 1, Lesson 7.4, Solving Systems of Equations by Elimination. So we're going to use the elimination, also called the addition method. All right, so just by way of review, remember there are 4 ways of solving a system of equations. That's important that you have those thoughts in your mind. When you come across a system, you need to think, okay, which method do I want to use to solve? You can solve by graphing, because remember, the solution is a point of intersection, so you can solve by graphing, not always the most accurate method. You can solve by substitution. We've solved with that method. Now today we're looking at the elimination or addition method, and then the fourth method we'll look at in Algebra 2, and that is solving using matrices. So solving systems of equations by the elimination method. All right, so let's go ahead and fill that in up here. Solving systems by the elimination method. Elimination. Again, also called the addition method. So solving systems by the elimination method. All right, so what's your objective? What are you after in this methodology? So here's your objective, and it's important that you keep this in mind. This is what you're going for. You need to get one of the variables. One of the variables. And what I'm talking about is the x's or the y's. Right? You're trying to get the x's or the y's. Get one of the variables to add out. Get one of the variables to add out. All right, so what our objective is if we can get one of the variables to add out, now we're going to have an equation with only one variable, and we can solve that. We can solve that. So how do you do this? How do you do it? Well, you need to look at the coefficients. Look at the coefficients, right? The multipliers of the variables. You do this to make a wise choice of which variable to eliminate. I'll show you this in a minute, but we're going to look at the variables and we have to make a choice. We have to make a choice. Am I going to eliminate the x's or am I going to eliminate the y's? We're going to look at the coefficients, and the coefficients will help us determine which one to seek to eliminate. All right, so how do you do that then? Let's suppose you make a choice. You want to choose to get rid of the x's or you get rid of the y's. How do you do that? You have to work to get the coefficients. Work to get the coefficients of one of the variables to be equal and opposite, so they will add out. Work to get the coefficients of one of the variables to be equal and opposite, so they will add out. All right, so let me recap here. What's your objective in this methodology? You got to get one of the variables, either the x's or the y's, to add out. What would make them add out? If you get their coefficients to be equal and opposite, they will add out. So it's important that you make a wise choice as to which variable you want to seek to eliminate. Okay? So that's the concept, and that's what we're looking for, and that's what we're after right here. Okay, so let's take a look at a couple examples here. All right, for A through D, choose which variable to eliminate and how to eliminate it. So that's all we're doing right now. We're not solving. We're just simply trying to make the choice. What do I want to eliminate? Do I want to eliminate the x's? Do I want to eliminate the y's? So you look at your x's. I got a 3x and a negative 7x. And then you look at your y's. I got a positive 2y and a negative 2y. So which one would you choose to eliminate? All right, hopefully you said the y's. And how would you do that? Well, if you look at it, remember, what do we want to do? Look at the top here of the screen. How do you get them to add out? Get their coefficients to be equal and opposite. Look what we have. Equal and opposite coefficients. Do you see that? So that's what you're after. So in this first problem, they're already ready to add. So how are you going to eliminate the y's? Add the equations. add the equations. That's all you need to do on this one. They're already equal and opposite. There's no further work to do. You're simply ready to add up the equations. Right? And so if we were going to continue in this problem, we would go to add the equations. Now look what happens if we were to do that. Positive 3x and a negative 7x is a negative 4x. The y's add out. Positive 2y and a negative 2y is 0, right? And then 7 minus 3 is a 4, and you can finish that off. But see how that's going to work? Now you're down to one equation with one variable that you can solve. All right, let's take a look at the second example here. So again, we want to make a choice. Am I going to choose to eliminate the x's, or I'm going to choose to eliminate the y's? So you got to look. I got a negative 4x and a positive 2 when I look at the x's. When I look at the y's, I have a negative 7 and a negative 5. Which ones are easier to get to be equal and opposite? The answer on this would be the x's. They are the easier ones to get to be equal and opposite. Now, they're not equal and opposite right now. How can you get them that way? So how? So I look at this and I say to myself, you know what? Instead of this being a 2x, if that were a 4x, they would be equal and opposite. If I multiply a 2x by 2, it'll be a 4x. So how do you do it? You multiply the second equation by 2. You multiply the second equation by 2. So we're going to take a bracket. We're going to put the whole second equation in a bracket. And we're going to put a 2 out in front. Okay? Now, when you actually do this, and we'll do some examples of the full problem in a minute, you would be distributing this 2 to each of the terms, making a new second equation. And our x's would be eliminated. Okay? That's the concept. That's the idea. Let's do another one. All right, so we take a look at this one. And again, my choice is, do I want to eliminate the x's or do I want to eliminate the y's? So I'm looking at my coefficients. I got a positive 4 and a positive 7. That doesn't look too easy there. Positive 5 and positive 5. Okay. They're equal. They're just not opposite. So, hey, I'm going for the y's, right? Let's eliminate the y's. How? You got to make a choice. Either multiply the top one or the bottom one by negative 1. So I'm going to say multiply the first equation by negative 1. So again, how would you do that? Put it in a bracket, put a negative 1 out in front. So again, when we are ready to finish the method here, we would distribute this negative 1. Okay, let's do the last example. Let me get this a little higher here. So here's our last example. So again, hey, we don't have x's and y's. That's all right. Don't sweat it. Not a big deal. But we have to choose, are we going to get rid of the a's or are we going to get rid of the b's? We'll start the exact same way. This is how you start every system of equations when you're going to solve by elimination. Your first thing is you have to decide which variable am I going to try to eliminate. So again, I'm looking. I have a positive 3a and a negative 2a. Okay. I have a positive 5b and a negative 11b. None of them is clearly an easy choice. But for me, the coefficients of the a's are smaller. One is already positive and another's already negative. That's a good thing. And because the numbers are smaller, I'm going to choose the a. Now in this situation, it's kind of like the concept of common denominators. So let me show you what I mean. Don't write this, but I'm just trying to get you to think. If you had a problem like this, 5/3 um, plus, let's say, 1/2. If you had a problem like this, and you're going to add fractions, your thought would be, hey, I got to get a common denominator. So you would say, let me multiply this one by a 2 on the bottom. Whatever I do the bottom, do the same thing on the top. And I would multiply 1/2 by a 3 on the bottom. Whatever I do the bottom, do the same thing on the top, so that I come up with a common denominator, right? Well, that's the kind of concept that you're going to use here. Okay, that coefficient that I'm after is going to be likened to a common denominator. Okay, let me get rid of all this stuff. We'll get back in business here. Okay, so that's what we're after. All right, and so in this situation, how am I going to do this? I'm going to multiply the first equation by 2. And I'm going to multiply the second equation by 3. So I'll bracket the first equation and multiply it by 2. I will bracket the second equation and multiply it by 3. That's going to give me a positive 6a and a negative 6a for my a's, and they'll be eliminated. Okay? Hey, that's not so hard. That's doable. Something anybody can do, and that's the idea, and that's the concept. So let's go on to some actual problems now, and let's solve the actual problem. All right, so number 3. Here we've got the system. We've got the black equation, negative 4x minus y equals negative 35. We've got a blue equation, 3x plus 2y equals 30. So our first choice, what do I want to eliminate, the x's or the y's? So you take a look. Now you could eliminate either one, but it's just usually easier. So you want to make a wise choice here. All right, so what did you choose? X's or y's? I'm going for y's. All right, if y was the choice, how would you do so? I'm going to multiply the black equation by 2. Right, multiply the black equation by 2. So let's go in and bracket the black equation. We're going to put a 2 out in front. All right, so we're going to end up with a new black equation. I'm going to do it underneath. So 2 times a negative 4x is a negative 8x. 2 times a negative y is a negative 2y. Ah, do you see how our y's are equal and opposite? It's what we wanted. Now, be careful here. A lot of students forget to distribute to the number on the other side of the equal sign. Don't forget that. And so we have then a negative 70. Okay, we have just accomplished the first part of solving a system of equations by elimination. All right, what do you do next? Next, add equations. So now add the equations. So I'm going to draw an addition line there. I'm just going to add them up. I get a negative 5x equals a negative 40. Right? Negative 5x equals negative 40. What would you do next? In this case, I'm going to solve for x, right? Things multiplied times a variable, you move by multiplying both sides by the reciprocal. So you can see right here, I'm going to divide both sides by negative 5. I end up with x equals 8. Always like to circle my solution. Okay, cool, we're moving right along. We have one of the values of the point of intersection, right? I know that the x value is 8. How can I get y? Well, I would get y the same way I would have gotten y in the other types of problems. I can now substitute x equal 8 into either equation to solve for y. And I could choose to use the black or the blue. It doesn't really matter. Black is probably a little bit easier here. So I'm going to take the original black. So let's write off to the side Now sub in y, oops, not y, excuse me. Now sub in x equals 8 and solve for y. Now again, it's your choice. I'm choosing the original black. I could also use the original blue. So I have negative 4, and where the x is, I'm putting a parentheses, minus y equals negative 35, and that 8 is subbing in for the x. Okay? Negative 32 minus y equals negative 35. Let's add a positive 32 to both sides. We get negative y equals negative 3, and therefore y equals 3. All right, and so what is our solution? Our solution is an x value of 8 and a y value of 3 in our point of intersection, 8, 3. And that wasn't too bad, was it? All right, so let me recap. First thing you're going to do is choose which variable to eliminate. We chose x. Next, determine how to do so. We'll multiply the black equation by 2. What do you do next? We added the two equations, the new black and the original blue. What do we do next? We solve the equation for the variable. What do we do next? We took that value and subbed it in to solve for the other variable, and now we have our point of intersection. Okay? That's the methodology. Once you do it a few times, you begin to get good at it and begin to understand all the aspects of it. Let's do another problem. Okay, so second example here. Get a little bit more room. So again, you're looking at the problem. What do you want to do first? You want to make a choice. All right, so take a look at it. What would you choose to eliminate, the x's or the y's? The x's or the y's? They're pretty similar. You know, you got a 2x and an x, you got a negative y and a positive 5y. You know, with me on this one, I'm going to choose to eliminate the y's. And the only reason I'm going to choose the y's is I already have a negative y and a positive y, which means then I would multiply the black equation, by 5. And here's the only thought here. It's the only reason I chose this one. If you multiply by a positive value, there's a little less chance of making a mistake. That's the only reason. When you distribute a negative, sometimes students will make a mistake. And so my only thought is using positives is a little bit safer methodology. Okay, that's the idea. All right, so remember now we got to distribute this 5. Why don't you go ahead and do that? Pause the video here if you want some time to do that. So let's distribute the 5, right? Here we go. All right, 10x minus 5y. Oh, that's good. They're equal and opposite. Equals negative 50. What comes next? We're going to add the two equations. Add the equations. All right, go ahead and add them. Again, pause if you want to see if you can get it correct on your own. It's 11x equals, what is that, negative 33. Now we're going to solve for x. Pretty simplistic. Divide both sides by 11. All right, do you remember what to do now? Do you remember how to finish? Okay, again, you can choose either the top equation or the bottom equation and sub in. Again, in this situation, I think it's easiest to use the top. 2 times x minus y equals negative 10. Again, I'm always going to use a parentheses. I'm going to sub in my value. That's the safest way to solve. All right. Again, pause it if you want to see if you can get it on your own. We get a negative 6 minus y equals negative 10. Let's add a positive 6 to both sides. We get negative y equals negative 4, so y is 4, right? What is our solution? It is the point negative 3, 4. Hey, not too bad. These aren't too bad. All right, solving by the elimination method. All right, let's try one more. One more. All right, so if you'd like to try this one completely on your own, go ahead and pause the video at this point and go ahead and solve it, and then you can go through and hit play and see if indeed you were correct on it. All right, and that would be my advice. Go ahead and pause the video, go ahead and try this one on your own, and then go ahead and play it at the end, and that'll be the ending of the video. Just a couple minutes left. Okay, if you're back, hopefully you looked at this and said, which one am I going to choose? Am I going to seek to eliminate the x's or the y's? It's 6 of one, half dozen the other. Now, if you made the other choice, that's okay. Just hold on until the final answer and see if you're correct, all right? I'm going for the y's again. Just the numbers are a little bit smaller. All right, how? I'm going to multiply black equation by a 5, and I'm going to multiply the blue equation by, now be careful here, I got to do negative 4. Now again, you might have chosen negative 5 and positive 4. That's okay. You're going to end up in the same place. All right, or if you chose the x's, then you would have gone what, 6 and negative 5, or negative 6 and positive 5. Okay? All right, let's see what happens. I'm going to get my new black. 25x minus 20y. Be careful here. Equals negative 115. I get my new blue. Negative 24x plus 20y equals 112. Next, what do? You add the equations, right? All right. Wow, x equals negative 3. Hey, I don't even have to solve that. It's already solved. That's nice. All right, got the value of x. I need to solve for the value of y. You know what? I've used the black one every single time. I think I'll just use the blue one just to be different here. All right, 6 where the x is. I'm going to sub in the value. What am I subbing in? Negative 3. All right, so let's go ahead and continue. So this is a negative 18 minus 5y equals negative 28. Let's add a positive 18 to both sides. Negative 5y equals negative 10, right? 28 negatives and 18 positives leaves me 10 negatives. Let's divide both sides by negative 5. Excuse me. And when you have with y equals 2, what's your final answer? Solution to this is the point of intersection where the x coordinate is negative 3 and the y coordinate is 2. Did you get it correct? I hope you did. Hey, that's the elimination method. So let me go back and recap for you here just briefly. All right, so remember, solving by elimination. Remember your objective. Get one of the variables, your choice, x's or y's, to add out. How can you do that? Look at B here. Get the coefficients to be equal and opposite. If that's the case, they will add out. So remember, you want to make a wise choice as to which variable to go for. Okay? Once you get that cared for, then it's a factor of adding the equations. Then it's a situation of adding the equations, and after you add the equations, you sub in and get the other variable. Okay? Hey, not so bad, not so tough. You can do it. Come into class tomorrow and work some problems in class. All right, have a great day.